to determine force in each member of the truss and to figure out either they are in tension or compression, given that we have two external load acting on the truss at point B and D having a magnitude of 10 kilonewton and 8 kilonewton respectively. We can utilize our method of joints to solve this problem. So picking a joint that have least amount of unknown, or at max two unknowns, because we only have two equilibrium conditions in the x and y axis, and these are two force members, so the moment equation won't be there. Starting with our joint D, we can go ahead and draw our free body diagram. Now on the free body diagram, I always go ahead and apply the loads in tension that will be pointing away from the joint. So our FCD and FDE is away from joint. We can go ahead and identify these forces by figuring out the angle first that DE is making. So our dimensions of the right angle triangle are given as 1 meter from C to D, 2 meter from A to G, that is equals to C to E. We can identify the hypotenuse using our Pythagorean theorem, that is coming as root 5. Once we have our free body diagram, loads and angle figured out, we can go ahead and apply our equilibrium equation of summation of forces acting along the y direction equals to 0. Simplifying, we get our value of FDE as 8 times root 5 divided by 2, that is coming as 8.94 kilonewton. Since the number here is positive, it means that the force in the member is in tension. Next, let's go ahead and apply our summation of forces along the x direction equals to 0, taking forces pointing towards the right as positive. So to start, our FCD is going towards the left, that's why it is taken as negative. Next, I have a component of force FDE going towards the left as well, so that will be our 8.94 times 1 over root 5. Here the value of FCD is coming as negative 4 kilonewtons. Now this negative sign is indicating that the force is in compression, because the direction I picked for the force on my free body diagram was in the tension direction. Now, this negative 4 kilonewton is indicating that the force in the member CD is in compression, because the direction I pick in my free body diagram was the tensile direction. The negative number is indicating that just it is opposite to the direction we have picked on our free body diagram. Next, we can go ahead and look at joint C. Now, looking at joint C, I can say there is our zero force member that is present here, because one of the rules is if a joint has three members and if there is no external force or support that is present on the joint and two of the members are collinear in the same line, whereas the third member is not, then the third member will be our zero force member. And we can prove that utilizing our free body diagram and applying the equilibrium condition. Again, at joint C, I'm always going to pick the forces in tension. That is the convention I went with. But you can decide yourself as well, either to pick the tension or compression direction. So in this case, starting with summation of the forces acting along the y-axis equals to 0. Here you can see that I have only one force, FCE, that is going in the upward direction, and we have no other load acting on it. That basically tell us that the force in the member EC is 0. Next, we can apply our summation of forces along the x direction. In this case, again, I have two forces that are pointing in the opposite direction. So both of them will have the same magnitude, and our FCB is coming as negative 4 kilonewton as well. Again, the negative sign is indicating that the member is in compression. Now, once we have figured out our joint D and C, we can go ahead and calculate the force in joint E. Now, for joint E, there are four members that are connected. So, in order to solve this thing, I at max I just need to have two members that are unknown. Since we have already calculated the force in the member CE and DE, we can go ahead and identify our forces in members FE and member BE. So for the member BE, that is also acting along an angle where the base of the right angle triangle is given as 2 and the height is given as 2 meters as well. That is the distance from B to F. Now we can simplify this as a ratio since they are equal. I can have a base of 1 and the perpendicular distance of 1. This gives me the hypotenuse of root 2 utilizing again our Pythagorean theorem. Now once we have our free body diagram, let's go ahead and start applying the equilibrium equations again, starting with summation of forces along the y direction equals to 0. I have negative FEB times 1 over root 2. That will give me the vertical component of force FEB. Then I have that zero force member, so there is no force there. Next, I have 8.94 kilonewton. Again, the component can be calculated by multiplying it with 2 over root 5 equals to 0. This gives us our value of FEB as negative 11.3 kilonewtons. Again, the negative sign is indicating that the member is in compression and the direction, actual direction, is opposite to the one that I have pointed out in my free body diagram. Next, let's go ahead and apply the summation of forces along the x direction equals to 0, taking forces going towards the right as positive. So we have our negative FEF minus I have a component of force in the member EB going along the negative x direction as well. That can be calculated by multiplying negative 11.3 with 1 over root 2, plus I have a component of 8.94 kilonewton going towards the right. That is calculated by multiplying it with 1 over root 5. Simplifying, we get the value of force FEF as 8 plus 4 equals to 12 kilonewton. Now, in this case, we have a positive magnitude. That means that the force acting in the member EF is in tensile direction. Next, we can go ahead and move towards our joint B that have one of the external loads acting on it. So in total, we have four members that are connected and one external load that is acting on it. But the only two members are unknown to us right now. That is a member from B to A and a member from B to F. Let's go ahead and start developing our free body diagram from joint B. Now, one thing to keep in mind, since I am picking the direction always in tension, if I have a member that is in compression, I'm just listing the magnitude as negative 4 kilonewton as shown here from B to C. Similarly, the member from B to E was in compression as well, and the direction that I'm picking is in the tensile direction. That's why I have as negative 11.3 here. Now, once we have listed down all the forces in the member, let's go ahead and apply our equilibrium equation again. In this case, starting with summation of forces along the x direction equals to 0, we can identify our force in member BA since it is going towards the left, taken as negative, whereas our negative 4 is going towards the right. That's why I have with a addition sign, and plus I have a component of negative 11.3 times 1 over root 2. This gives us the value of force in member BA as negative 12 kilonewton. Negative sign again means that the force is in compression in the member BA. Next, let's apply our summation of forces along the y-axis equals to 0. In this case, the only unknown I have is the force in member BF pointing upward, whereas I will have a component of force negative 11.3 in the vertical direction that is calculated by multiplying it with 1 over root 2, and then my external load is acting downward. That's why it is given as negative 10. Simplifying, we get our value of force in the member BF as 18 kilonewton. Now here we have a positive number. This is telling us that the member is, or the force in the member is in tension. Now, finally, let's move to our joint F and identify the force in the member GF and FA here. So, again, developing our free body diagram, the force in the member FE is 12 kilonewton in tension. That's why it's taken as positive, whereas a force in the member Fg is unknown. That's why we have given it as a variable. I have an 18 kilonewton force in the member F2B in tension direction, whereas the force in the member Fa is also unknown. Whereas we can calculate the angle it is making from the base AB is 1 meter and our FB is 2 meter. So the hypotenuse will be root 5 utilizing our Pythagorean theorem. Now, once we have our free body diagram, let's go ahead and apply our equilibrium equation of summation of forces acting along the y direction equals to 0. In this case, we can calculate our force in member AF, that is going downward, taken as a negative sign, times 2 over root 5 minus 18 equals to 0. And if we simplify that, we are getting the value as negative 20.1 kilonewton. Now, again, the negative sign is indicating that the force is in compression. Now, finally, our last equation is summation of forces along the x direction equals to 0. Here, our force in member GF is going towards the left. That's why taken as negative. Again, our FAF x component will also be pointing towards the left. That's why I have negative value as well. Finally, I have our 12 kilonewton going in the positive x direction. Simplifying, we get our value of force in member GF as 21 kilonewton. And here again, the number is positive. That's why the force is in tension in the member here.